What do you notice about the graph of a cube-root function? We already know this, but what does it look like? The shape. I don't really care where it moves. What is it?
I told you, it's a crooked S.
Looks like a crooked S or a snake. Okay.
It moved to the left.
Now I want you to graph this one. So go into your back y equals. Now clear out the old one. Now you remember how to type in a fifth root?
No.
Yeah.
You do.
Well, you know,
5 math
or you can just
x root is 5.
do that. Replace it.
And then x minus 7. And then you have to make sure you arrow out. Make sure you arrow out of the square root plus 3.
It's a long kind of. How do you get the arrow?
Now I'm going to do a, this is a good review. Hit zoom 1 with me.
Oh, yours isn't working.
And what I want you to do, we're going to do zoom box. So this is where literally nobody should be talking right now. You're going to move your cursor kind of near it. I want this shape right here. I want that kind of like the center of the graph. So get the cursor kind of the top left corner, hit enter, and then that allows you to drag a box around the graph that you want to see. So I'm going to kind of drag it down, and then you'll see it kind of start to form a rectangle. I want to zoom in to this part of the graph so we can really see that shape and what's happening right there. And then hit enter, and it will zoom into that part. And what do you kind of notice about the shape of the fifth root?
It doesn't
Why is
have
it like
a
that?
certain color.
Yeah, it's there. The calculator's trying its best, but can you still see how it's kind of like the S shape? It's a little bit more steep because the fifth root is giving you a lot different outputs. That's a lot smaller outputs than the cube root. Okay, now go back to y equals.
Why is there like a blank?
That's just, it's so smashed in, your calculator struggles to graph it.
It's confused with me.
Now let's do the seventh root. So do 7 math 5. The seventh root of x plus 4 minus 1, and then hit graph.
Alright.
Now, it's still going to be zoomed to that box, so hit zoom 6.
This one's kind of sad.
Why?
Look at it.
That's mean.
Where are you? Once again, these aren't the best screens, right? But you can tell that it still has this kind of S shape. It's really shallow because seventh roots are really small, right? Like, what's the seventh root of 2?
Oh, small little line.
0.0007.
Yeah, it's like a really small number. So the bigger the root, it's going to get like shorter and shorter and shorter because our outputs are getting way smaller. Okay. So now what I want to do, what do you want to do? So what did we kind of determine about all of our odd roots?
The outputs get small.
Yeah, and the shape is kind of that, it's the snake shape. All of them. 3, 5, 7, if we kept going, 9, 11, 15, 13, they're all snake shape. Okay, now I want you to graph this one here.
Alright.
So graph the square root, and we already know what a square root looks like, but a square root of x plus 2 minus 6.
X 2 minus 6. Ooh.
Now we know this one left 2 and down 6, so you can see that. But what shape is this? Yeah, I call it like an up and over. It's kind of like a curve. One up and over curve.
It's like a bottom
Okay, go back to y equals. Now I want you to graph the fourth root. So 4 math 5. The fourth root of x minus 7, arrow to the right, plus 3.
Why is there like plus? I can't see. Why is that consistent? Why is that consistent? Is it just like the best image or something?
Yeah, I just picked random numbers and put it in left and right. Now once again, let's change our window. Is the graph going to be over here at all?
No.
No, so let's change x minimum. The furthest left that I want it to go is 1. But I want to change the x max. I want it to go further to the right. So I'm going to change it to like 20. And then hit graph again. Now, can you see how it's still the up and over shape?
Yeah.
It does not have the other half that our cube and fifth and seventh roots had, right? It's only the right half of it.
Because it's even.
Because it's even. We're taking the even root. And then the last one I want you to do is 6. The sixth root. So 6 math 5. The sixth root of x plus 4 minus 1. Now this one's super shallow, right? Kind of like the seventh root, because it's asking you what number times itself 6 times is that number. So it's a really small output. But let's go back to Zoom 6. Let's change. See how it's kind of like rubbed up against the x-axis right now. Let's change it to like let's change the k value to, I don't know, +8. No, let's do +4. Just so we can get it above the x-axis a little bit, and we'll see that up and over shape a little bit better. Now it's up and over, but it's really shallow, right?
Yeah.
So our square root started like up and over, and then what did our fourth root do?
It's a little tiny.
It was still up and over, but our outputs were smaller, right? And then the sixth root, it was still up and over, but it was even more smashed, right? So you can kind of see the way that the root affects the outputs, but regardless, what shape were all of our even roots? Yeah, like an up and over is what I say. You can call it whatever you want.
Infinite rainbow.
So odd roots are going to be your snakes. Even roots are going to be your up and overs. So which ones have a domain and range of all real numbers always?
Snakes.
Snakes.
So Ray.
So all of these would have all real numbers, domain and range. These ones determine where the up and over starts, right?
Mm-hmm.
Wait, so what if it's like?
For domain of this one right here, this went left 2, right? Down 6. So left 2, 1, 2, 3, 4, 5, 6, down 6, and then it went up and over. So the domain, what's the furthest left that this graph ever went? -2 to infinity. And the range, what's the lowest that this graph will ever hit? It's that k value. So -6 and up forever. Domain range of the 111th root of x plus 4. Yeah, it's all real numbers, right? How did we know that so fast?
Because it's an odd.
Yeah, if this is ever odd, it's always going to be all real numbers,
7,001.